chemistry as makeup. Like that is
I love
apparently
that.
the analogy
Let's
now.
just go with that analogy forever. And there's a lipstick, but there's a mascara, and they're
Right.
so
Yep.
different, but they're similar. Yeah.
But they're similar. They're all related. Yeah, that's what chemistry is. Chemistry is makeup. Hi, I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to lesson 89. We are in our What is Science unit. And this week, Cheryl, we get to talk about chemistry.
Yay? Question mark?
Uh-oh. Are you intimidated by chemistry?
Yes, I was about to use the word intimidated. I think I am intimidated by chemistry. Yeah.
Why? What's intimidating for you about chemistry?
Oh gosh. Well, okay. I was going to say something that I guess applies to all science, but it feels like it applies to chemistry more. I don't know if this is true or not. Of like, either you know it or you don't. Like it, which you could say that of everything, right? Like
Sure.
there's just in science in general, especially when you're looking at these broad overviews that we're doing, it's like memorization, right? Of like, what's the order of the things in biology, different things like that. But with the chemistry, I think it's the periodic table is like, I don't know, that's just memorization. Or like what makes up a compound, I don't even know. Like it's like, well, you know those things or you don't, and so it feels very intimidating. And then I think on top of that, I don't know if I know enough about it to even feel like I would have a foundation to guess upon. So I think that's what it's just, this whole like big question mark.
Yeah.
It's like, you're so pumped right now. It's really funny.
I am. Yeah. You could see, well, because you mentioned something, and we'll get to it. I'm gonna save it for a little bit. You mentioned something that I'm really excited to talk to you about now, based on what you said. And we may go totally in the wrong direction. I don't know. We'll see where the rest of this goes. We need to first go into the pre-assessment, though, and find out what you know about chemistry. Let's start really broad and then work our way down. In general, what is chemistry? What does chemistry study? What is it trying to explain or learn about?
I think that it's studying like how different things are made up. Like, what are they made up of? And what are the properties of the things that they're made up of? And I would guess that in practicality, a lot of chemists are then trying to figure out how to use existing things to like find new purposes or solutions to things. So like if you were a chemist, but you're like working in medicine, maybe like coming up with new vaccines or things like that. Like I think that's under chemistry.
Okay.
Maybe it's not. Maybe there's a different classification for that or something, but that feels chemistry like to me. Or like if you're working in like skincare, you're like making new like skincare products, then you're figuring out like, what can I put in this that is shelf stable and good for skin and these other things, but not going to cause this problem. So like, I think there's like so many variations of that I would guess are kind of similar, of like foundational and then just applied in all sorts of different fields and ways would be my guess. Why are you laughing?
I'm sorry. Because when you had just said, and you said foundational, and in my head I was thinking makeup, because you were talking about like, and then you said that can be applied in so many different ways. And I was just like, I just kept picturing like chemistry as makeup. Like that is apparently the analogy
Let's
now.
just go with that analogy forever. And there's a lipstick, but there's a mascara, and they're so different, but they're similar. Yeah.
But they're similar. They're all related. Yeah, that's what chemistry is. Chemistry is makeup.
Yeah, there we go. Well, I do think about, there's this podcast I love that isn't going anymore, but I think people could listen to back episodes of it, called Natch Butte.
Oh, you've told me about it before.
Jackie Johnson, she's a comedian and an actress, but she loves makeup and skincare. And so she has this she's had this podcast forever, where she talks about makeup and skincare and hair care and all these things.
Mm-hmm.
But she's had on these recurring guests that then now I think they have their own podcast and Instagram and all these things called Chemist Confessions. And they're
Oh.
both chemists and they look at different brands and they say okay, we know that you're supposed to a lot of people recommend niacinamide in things, but you actually want this percentage of it. And this one has way too much and this other one has way too little. And so this one's actually going to be good for your skin because of this. So they look at the chemistry of
Mm.
skincare and makeup and things like that to
Yeah.
actually talk about the real effects on skin. And I think it's fascinating that I know there's probably a million chemists that are doing that with skincare
Mm.
because the beauty industry is massive.
Yeah.
But also, it's so cool if that's actual chemists doing that work who actually
Mm.
know what they're doing and they're not just putting random crap together, but they're actually thinking about how if you want to actually improve your skin and take care of it, there is
Mm-hmm.
chemistry behind that. And so
Yeah. Yeah.
yeah.
Okay. We should probably also talk about the non-cosmetology version of
Sure.
chemistry.
Yeah.
What other things do you think might be connected to chemistry?
Oh gosh. Probably
Ideas,
so much
concepts.
food science, I would guess,
Okay. Okay.
artificial foods, I would imagine.
What, like when you say
Um,
artificial food, what do you mean by that?
um, well, I think about fast food and that
Okay.
they want
Okay.
it to taste good. And I
Okay.
think there is some chemistry behind some of that, I think. Um, or I don't know, candies that are being made. I think there's a lot of chemistry and artificial flavoring or different things like that. That's what I mean,
Mm-hmm.
lab made edible
Okay.
things. I
Okay.
think in the food
Okay.
industry, I'm guessing there's chemistry
Okay.
involved in that.
All right.
Like everything, I start doubting it the more I talk about it. Um, okay, and then I'm guessing medicine. It's gotta
Okay.
be.
All
There's a
right.
lot in the area of medicine. Um, makeup, medicine, food. Those are the
Makeup,
things.
medicine, munchies.
There we go. Yep.
There's
The
the
big
M's.
3.
Okay. Okay. And when when you think about what what a chemist might actually do to do in any of those fields, what sorts of things are they trying to understand in a substance? Do you think?
I'm guessing that they're trying to figure out its effectiveness, like,
Okay,
in
but
the
like
area of,
how? Like what are
trying
they
to make
trying to,
things.
but yeah, but what are they actually looking at in the substance to figure those things out?
Um, they probably do a lot of tests
Okay.
and have a control. That's the one
Oh
word I
boy.
know. From the beginning of this podcast, I knew the word control, and I just bust it out whenever I can. I'm guessing they, think "Oh, we think that this affects this other thing. Let's make a thing and try it." I don't know how to describe it further than I have a
Okay.
very narrow idea of how this works.
Yep. Yep, you do. Yep. Okay, let's go in a different direction. One of the things you mentioned
Okay.
was the periodic table.
Ugh, yes.
What do you know about the periodic table and why did you go, "Ooh"?
It's so much memorization. It'd be like asking me to, tell you about listing the 50 states and capitals to you, where it's a whole long list of things. Okay, so I know that they are grouped. There is a grouping involved. There is a rhyme and reason to the order of the periodic
Okay.
table. I think that there are all the metals are grouped together, stuff like that. I think they're kind of grouped by
Okay.
type. And there are numbers involved that do have a reason behind them. They're not random numbers.
Okay.
And I don't remember purpose or like what those numbers are because it's not like weight, but like there's something to do with numbers that actually is related to each element and makes sense.
Okay.
Not just a
You
random
said
word.
to each element. So what's an element?
Okay, I'm not going to define this well.
It's okay.
It's like a single ingredient.
Okay.
So, like the elements then make up everything, but it's
Okay.
not like H2O is not an element, but like the H is an element and the O is an
Okay.
element. And so it's the single, I don't know. I can't think of another word other than ingredient or using the word
Mm-hmm.
element again. Um, um,
Okay.
but they make up all the recipes that make up all sorts of things, kind of like how flour and sugar and butter are each individual elements and they make up a
Okay.
cookie. Um,
Okay.
and there's facts about them on, and they each have a shortened, um, can't think of the word now. 1 or 2 letters.
Abbreviation.
Yes, thank you. Abbreviation, yeah. Um, and then you just have to try to memorize them, I guess, if that's something that you need to do.
Okay, so here's what the sense that I'm getting is in our quiz, I need to just say as many as you can, and the
Oh
more you get, the better
gosh.
you do. Does that sound like a good
Oh,
plan?
goodness gracious. It depends on what your goals are for this lesson, Ryan. Is that one of your objectives?
Yeah, it is.
Okay, dang it.
To make Cheryl feel as uncomfortable as possible.
Oh, no. Well, it's happening.
I don't really want to make you uncomfortable, Cheryl. That's not actually my goal.
Oh, good.
But I am actually very excited about the periodic table. And the fact that you're so sad about it makes me a little sad. And hopefully, I can help you feel a little less terrible about the periodic table before we're done today.
Okay, that sounds fantastic.
All right. Let's start with what is and what's on the periodic table and what are each of those little squares. Each of those squares is an element, which you knew. You knew that those were elements, talked about it. You were also correct about what an element is in the example you gave. You gave an example of our good friend, water, H2O.
Oh, Mickey Mouse popcorn.
Yep, I brought in the little model again because I know you like it, right?
Mhm.
And then in this example, the two little white ones are the H's, and the reddish orange one is the oxygen, the O. And those are those abbreviations again that you talked about. And each type, so in this case, each color is an element. Hydrogen is an example of an element. Oxygen is an element. And I like what you talked about when you said they're ingredients, because they totally are. They are ingredients that make up literally everything in the entire universe. If there's a thing, it's made up of some combination of these elements. And the thing about an element is it's the smallest unit of a thing that is still that thing, has the properties or behaves like that thing. So if you take hydrogen, if you split it into smaller pieces, it's not really hydrogen anymore.
Mm.
You can get a bunch more of it. You can have a whole bunch of hydrogens, lots of these white ones, all together, tons and tons of them, and it still behaves like hydrogen. But if you split it down to less than whatever this is, then it's not really hydrogen anymore.
Hmm.
Okay. And this is an atom. You didn't really mention that term, but I feel like that's
See,
kind of
I
an important
forgot if
one.
atoms were smaller than that or if that's what the
Yeah.
atom was. Okay. Got it.
Yeah, and no problem. But that's kind of a foundation of all of chemistry, so I figured we should talk
Fair.
about it.
Yeah,
Right?
yeah.
And so you can have a hydrogen atom or an oxygen atom, which is sometimes confusing because each of those are also elements. Right?
Mm.
Hydrogen is an element, oxygen is an element, but you could also have atoms of hydrogen and oxygen.
Cool.
But you put it
Okay.
together and you were right, like water is a molecule. It's a combination of
Mm-hmm.
multiple atoms together. And in this case, different types of atoms.
Great.
Okay, we're good so far.
Yeah.
Let's talk about the periodic table.
Okay.
I love the periodic table. And it's interesting because the reason I love the periodic table is because it has nothing to do with memorization.
Really?
Now, when I was in school and when you were in school, yes, I was required to memorize like the first 20 elements in the periodic table.
Yeah.
Fine. I think that's a waste of time. Every time I've taught some version of chemistry, I have told the students they don't have to memorize anything. Anytime I gave them a test, I gave them a periodic table. The periodic table, if you know how to use it, gives you answers. It has so many patterns in it. It's amazing. I love the periodic table, but I didn't know that until I took chemistry in college. And I had a great chemistry professor who I would say kind of unlocked the periodic table for me and helped me understand all of those patterns and why it's so important and so cool. I would
Brian,
like
I
to
think
show
we just
you.
found your new YouTube series called Unlocking the Periodic Table.
There's so many more people that are more qualified than me about that, but that's a cool name. That would be a cool name. I'm going to go ahead and share my screen so you can see a visual a little bit of the periodic table and the information it has.
Sounds good. And I will remind our listeners, if you are only listening to this podcast, we are also on YouTube and we can see all the pretty colors in the periodic table.
Yes. This is just the periodic table in Google, which I didn't know that it did, but Google keeps doing more and more cool things. And I discovered something very, very cool that it does, which I'll get to in a minute. But you notice that there are different colors.
Yes.
And that's part of what you mentioned, where there's different types of things and there's groups of things and categories. And they're listed down here on the bottom a little bit. Things like alkali metals and metalloids and actinides and noble gases and things like that. And they're color coded, and that's cool and that's great. And you can get a whole lot. Like, for example, helium's over here. Neon is a great one, right? So these are all the noble gases here on the far right. And then you've got the alkali metals over here and a whole bunch of things like that. Those things can be helpful, but are not, for what you're thinking about, not as big a deal. The patterns come when we actually look at individual elements. And this is what I love. When we look over here, it does like a little mini model of the atom, which I absolutely, and then you can like move it around. And so the red thing there, in this case, this is different than like my model of a water molecule. Okay.
Yeah.
So in this case, the red one represents the nucleus of the atom, the center of it, specifically a proton. And then the little green one is an electron. I don't know why it keeps spinning so much. I'm trying to like get it to stand still. There we go.
It just looks like Saturn, but that's fine.
It does a little bit. This is the simplest atom that exists, hydrogen. One proton, one electron. That's why it's number 1 on the periodic table. When we look at number 2,
that's what it is, because I remember the numbers. Okay.
We look at number 2 is helium. Now this is what helium looks like. It has 2 of the red ones, which are the protons, plus 2 of these new ones, these blue ones. Those are neutrons, and then 2 electrons. And they kind of move around.
There's a whole blob in the middle.
There's a whole blob. That's the nucleus. Okay. And as you go up, as you increase number, you keep getting more and more things in that blob.
Whoa.
But they go up.
This is so cool.
Isn't this fun? Way to go, Google, right?
I know.
Literally, all I did was Google periodic table, and this was the top thing that came up.
Oh, I love it.
Yeah, it's great.
It's a good diagram.
It is, except that it's inaccurate, but that's a separate issue. It's useful. It's useful for what we're doing right now. And so you can all of a sudden start to see a bunch of patterns with this. And you don't need to know all the patterns, but I'm going to bore you with some of them. Okay. So every time you go from one row to the next row, you gain another little circle going around it. Do you see how now we've got 2 circles going around it? And now I go up here and I've got 3 circles. Go to the next
So
one
that's why
down.
there's all
We
that
have
blank
4
space in
circles.
the middle and the top of the periodic table.
Yes, exactly. All the blank
Oh,
space is
yes.
because of the way these things fill up, because each of those circles, called an orbital, can only hold a certain number of the green ones, a certain number of the electrons. That first one
Yeah.
only holds 2. You can't have more than 2. That's why there's the hydrogen on the far left, and then a whole bunch of blank space, and the helium on the right. Because
Wait, can
all
I
the
see
rest of that just,
number like 9 then?
yeah. What would you predict number 9 might have?
Well, 9 little green things going around, but only 2
Yep.
circles, which feels
Yep.
like it's different than what you just said. I thought you said you can't have more than 2.
You can't have more than 2 in the first orbital.
Oh, so then
But
the
not
one
all
further
orbitals.
out has 7.
Uh-huh. Right,
Okay.
because that orbital can hold 8 total. And that's why
Oh, so
there's the
that's why
gap
we can have
here.
10 there, but we can't have 11.
Exactly. Uh-huh. And so then we go down
Okay.
to another one, and so the third one also holds 8, but then the fourth one can hold even more, which is why there's even more across. And so if we go like
That
all the way
is
down here, you can see like all these crazy numbers of electrons.
so wild that just by adding an electron, it becomes something totally different.
Well, technically it's adding protons, but yes, that's what makes the difference, is actually the number of
So
protons.
interesting.
It
Okay.
is. And so do you see how there's these patterns built
Yeah.
into the periodic table? And you mentioned weight, and you said it's not weight. Well, actually it is. We call it atomic mass, but that is
Are you
one of the
serious?
numbers that's usually on there. So in this one, they're organized a little bit differently. In this one, we're looking at krypton. So 36, that's the number of protons and electrons. And
Yeah.
then the 83.798, that's the average weight or mass of one krypton atom. And that's in
So
atomic mass units, but
does the mass go up each time?
what do you think?
Well, I would guess, yeah, that it would keep
Because,
going up. Well, because there's more stuff in it.
all right, let's look. So this is 36. So let's look at 37. So this is 83.7. The next one,
85.
85.4. And
Yeah.
then the next one,
Interesting. Okay.
87.6. See, and
Yeah.
you're already starting to notice the patterns.
Yeah.
So it's not a random grouping. It's actually a
Mm,
really useful grouping of the atoms. And then chemistry, now we're kind of moving back out again, is
okay.
how do atoms interact with each other to make things like molecules, like a molecule of water? And then how do those molecules interact with each other to make, for example, I think I used this one way back when, like a molecule of glucose, so a much, much bigger one, right? So this one has, do you like it?
It's it's so blobby.
It's so blobby. It really is.
Yeah.
It's so blobby, right? But it also has, then this says the black one on here, which that's carbon, right? So we've got another type of atom, another element, right? Carbon, which is on the periodic table here, number 6, mass of 12, right? And so all of these, but this can break apart and come back together again, and they get
Mm,
rearranged. And so knowing how all of these things interact with each other, that's really what chemistry is all about. And
mm.
that leads to where you started, which were the applications of chemistry.
Yeah.
So when you start thinking about things like food science or medicine, or what else did you talk about? You also talked about like beauty products.
Mhm.
That's what chemists are doing to figure out how does it do the thing you want it to do. They have to think about how do the atoms and molecules interact with each other. If it's a beauty product, how does it interact with, let's say it's going on your skin, how do those molecules interact with your skin? What are the reactions that they do? How do they like work together? How do they work against? How do all of those things interact? In medicine, it's how do the things that we take as, as medicines or whatever, how do those interact with our bodies to change chemistry in our bodies? in a whole bunch of
Mm.
different ways. Or sometimes if it's medicine as far as like trying to fight an infection, how do they change the chemistry of that infectious agent? How does it change the chemistry of a bacterium or of a virus? How does it change those things, or of a fungus? Right? Think like athlete's foot. That's a fungal infection, right?
Mm.
How do you treat that? How do you change the chemistry of those substances to our advantage?
Cool. I feel like that's what I said.
It's basically what you said. Yeah, that's basically what you said. You're right. Yeah, exactly.
Well, I
How
feel
did I
like
not
that
get that?
makes sense, and it was a hard thing to articulate, you know what I mean? But yeah, like,
Yeah,
that's really
yeah,
cool.
yeah. And then there's whole other parts of chemistry that we didn't get into, but you've actually already learned. Which, remember when we did the hot and cold unit?
Yeah.
That a lot of that is actually chemistry. What happens
Mm.
to atoms and molecules as their temperatures change? How does
Oh,
that affect
yeah.
things, right? Remember we talked about the speed at which molecules are moving. That's
Mhm.
chemistry. There's some physics in there too, but that's chemistry. Chemists study those sorts of things. That's why, like the Bunsen burner, sort of the stereotypical science classroom, chemistry classroom thing. You're heating stuff up and seeing what happens. Chemical reactions happen at a faster rate when they're hotter than when they're colder, because those atoms and molecules are moving faster. So they're more likely to run into each other and change and interact and do all of those things. So there's a lot that goes into chemistry. And it's
Mm.
really, I think, pretty cool, pretty interesting. And the periodic table, even though chemists don't necessarily like sit down and look at it all the time, but the concepts and the ideas that the periodic table encapsulates really underlies all of the things that is done in chemistry. Now, again, you may not need to reference it for everything that you're doing as a chemist, but those patterns and those interactions and those things are represented in the periodic table, which is why I get really
Mm.
excited when I think about the periodic table.
That actually has a lot more rhyme and reason than the states do then.
I mean, I think so, but I also have a strong bias as a science person to think that there's a little bit, more used to that. I'm sure that if we had a geographer on, I'm sure they could tell us the rhyme and the reason behind those things as well. But that's not me. I'm not
Sure.
a geographer.
Yeah. No, as far as, like, placement compared to each other, you
Oh,
know what I mean? And,
sure.
like, the facts
Yes.
about the thing and everything. Again,
Yeah.
probably a geographer would have more to say about it, but yeah, that's really cool.
All right, Cheryl, it's now time for your quiz.
Um, it depends on how much memorization you need for how comfortable I'm gonna be with this.
Okay. I would like you to give me all of the elements on the periodic table. Ready, go.
You want me to hand them to you, or do you want them,
Yes.
like, in an email? I'll just
Yes.
copy and paste in an email for you.
Okay.
How
Oh,
about that?
oh, how about this? This has nothing to do with your quiz, but I forgot it.
Yes.
Stay right there.
Oh my gosh, Ryan ran out of his room, and now all we have to look at are his Star Wars posters and a cute little Grogu. All right, he's now back, and he looks
Okay.
very excited.
I am excited, but I'm going to save this till the end.
What?
Okay.
Dang
Question
it.
number
Okay,
one.
fine. Whatever.
What is an element?
The smallest okay, an element is an atom, and it is the smallest that a thing can be before it's no longer that thing. And by thing, I mean ingredient, and the elements are the ingredients that make up everything we know in the universe. That was not like a great order. Like, I think all the words were
It
there.
wasn't. Yeah. Yeah. I think you got part. So, what's the difference between an atom and an element?
Well, atoms are atoms and elements are different. You look so disappointed, like
I mean, that
so
is such.
disappointed.
Yeah,
I
I mean,
know.
that's
Okay,
not a
hold
good
on, hold
answer.
on, hold on, hold on. An atom is very small
Yes.
and it has a nucleus
Yes.
and at least one electron
Usually.
minimum.
Usually.
Um, and a proton or then some.
Uh-huh.
Okay. An element is what kind it is, and you can have a whole lot of it or just one atom of it.
Yes.
Is that a better
Yes.
distinction?
That is better. Yes.
Okay.
Good job. Yeah. Yes. I like that. So that was question 1 and 2. Question
Ooh,
3.
yes.
What are 2 patterns in the periodic table?
Okay, so the elements are numbered 1, 2, 3, 4, 5.
Mhm.
All of the numbers just in order.
What's
And
the
those
pattern with
numbers
that?
are
Okay. Yeah.
I'm getting there.
Okay, okay. All right, all right.
Then those numbers represent the number of electrons in each of those elements.
For the purposes of what we talked about today, I will say yes.
Oh
Technically,
no.
it's the number of protons, and it also is
Ooh.
usually the number of electrons,
Oh
but
no.
it's not always
Okay.
the number of electrons. But we didn't really talk about that, so you wouldn't really know that. But because you can actually change the number of electrons that an atom has, and it'll still be the same element. But if you change the
Oh.
number of protons an atom has, you change what element it is.
Whoa.
Yep.
Interesting.
Yep. Yep.
Another pattern is
Mm-hmm.
that if you go down a row,
Mm-hmm.
then it gets one more circle
Mm-hmm.
around it.
Yep.
And those circles are what the little electrons revolve around. Yeah.
Yeah. Revolve around
Cool.
the nucleus. Yep.
Yeah.
Yes. And I sort of implied this before. They're not actually circles. That's not actually the way atoms look, but that's the simplest way that we kind of represent them. But
Okay.
I would be remiss if I didn't mention that again. But yes, based on what we've talked about, what we saw, yes, that's great. Question 4. Why are there weird gaps in the periodic table?
The why is in order for them to stay organized. Um,
Okay.
and so there are only 2 in the top row because if there are more than 2 electrons, then there has to be more than one symbolic circle. Um,
Symbolic circle. I like it. Yes.
yes.
Yeah.
And so they're just in, and then there's a lot more than 2 when you get down further that are still that same number of circles. And so
Mm-hmm.
I guess like the reason they're on the edges and not like somewhere in the middle is just so they line up with the ones that they're similar to. It would be my guess.
Yeah, you're exactly right, because
Okay.
we didn't talk about that. Yeah, you're right. You're right. And there's a whole lot more that we could talk about as far as why. But yes, it's so that they're more in line with the ones they're similar to. Way to go, Cheryl. You
Thanks.
inferred an additional pattern.
Ooh, so fancy.
You are fancy. Next question. How is cosmetology, medicine, or foods an applied version of chemistry?
Because people who work in those fields use I mean the okay, I'm gonna say something very simple and then hopefully expand upon it. They
Okay.
use chemistry in their jobs. Like they
Okay.
use
Yeah.
chemistry in order to do the work that they need to do. And so they're looking at what things are made of down to the level of elements, and I'm guessing and further up into
Mm-hmm.
different other ingredients that are more complicated than that, and what happens to those things and how to use and manipulate um, ingredients of elements or um, other like combinations of things or what they do to them and how those things have an effect on like whatever the work is that they're doing in order to get their desired result.
She says as she continues to try and make it flowery at
I
the
know.
end.
I think eventually if I say enough words, we'll get some that are helpful.
And sometimes that's true, and sometimes it's not. Okay. Last question, and then the bonus surprise.
Okay.
Why is the periodic table cool?
Because it's organized and it has a reason behind it, Ryan. That's what I'm guessing you would say.
I mean, you could say anything, but I love that as a reason.
Yeah.
Great. Okay. So I was really excited because I forgot that I have my favorite element here. And I don't remember if I've showed it to you before or not. I think I might have.
It's very shiny.
It is very shiny.
And it's in a little bottle.
Yes, you have seen it. Do you remember what it is?
Mercury. And it's really heavy.
It is.
Oh my gosh. You know what's funny though is that especially without holding it, just you showing it, it looks like it's from a craft store and it's some thin, too thin silver paint.
It does look like that, doesn't it?
Mm-hmm. Yes.
Yeah, but if like I shake it around or whatever and that like comes back together, there's no like dots.
Interesting.
It's so cool. And you have, I have shown you this in person and you've been here before. What do you remember about it?
Well, it's dangerous.
Yeah. Well,
it's really heavy.
Yeah.
Yeah. Which is weird because it looks like it would not be that heavy because it looks like a really thin liquid.
Yeah.
And that is purified, right? Like that's why it's that shiny.
Mostly, yeah.
Okay.
I had to do some filtering of it to get it like this because it was actually really dirty when I got it. So there you can get it. And I didn't like if I had used some chemical processes, I could get it way better. But like you said, it's dangerous. So I'm trying to be safe. So and it's the only go ahead.
And if all goes well, you're gonna see a mercury fountain next week in Barcelona, Ryan.
I hope so. I hope so. We'll see how that works. But yes, I hope I'll get there. I'm very excited. That'll be the most mercury I've ever seen in one place, which will be very cool. I won't be able to touch it though, which is too bad. What? Why is that funny?
Because you're a science nerd. You're just like the fact of like, I would think it was cool for different reasons. Like I think like, ooh, pretty. Like what?
It's also pretty.
Like, it's cool because it would be the most mercury I've seen in one place.
Right, because mercury is pretty rare for us to run into these days because it is toxic. So, but it's very, very cool. I love it. It's the only metal that is a liquid at room temperature.
Oh,
which is very cool.
Unique.
It is very unique and it is very cool. And I couldn't talk about elements without talking about it. But I've definitely talked too much about it now. And so we are out of time. We are out of time. I need to stop talking. Why don't you pack up your stuff and get ready for my closing remarks? You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.